Hello, welcome to my channel. In this video, I'll be discussing stoichiometry of chemical reactions, which is one of the topics you are expected to be familiar with before you go for JAMB UTME exam. Stoichiometry is the quantitative relationship between reactants and products in a chemical reaction, and it is based on the conservation of mass, which states that matter cannot be created nor destroyed. Why do we talk about stoichiometry? Stoichiometry helps us to predict the amount of the product that will be formed. If you watch my video on chemical reactions, we talk about the basics of chemical reactions in chemistry. And chemical reaction is usually represented with equation in which there is reactants and product is formed. Okay, and I talked about the different types of chemical reaction. I think you should watch that video for the basics that you need to understand this video. Okay, so stoichiometry helps us to predict what the amount of product will be. Okay, and it also helps us to determine the amount of reactant that is needed in a chemical reaction. This is very necessary in the industries where chemicals are produced, okay, from another chemical. And knowing this can help us to optimize resources both in the industry and the laboratory settings. Okay. Now, in stoichiometry, like I said earlier, that it can be used to calculate the amount of reactants required or the amount of products. Let's go through this example so that we can have better understanding of what I'm talking about. They ask us in this question that's how many grams of water are produced when 4 grams of hydrogen reacts with excess oxygen. When you are faced with this kind of question in exam, the first thing for you is to write a chemical equation that will show the process, and every chemical equations that you write in chemistry should be balanced. So you write the chemical equation, and the chemical equation for hydrogen reacting with oxygen, I don't think is strange to us. Hydrogen plus oxygen to form water. Okay, we've written the equation now. The next thing is to balance this equation. Okay, and in the video that I did on chemical reactions, I told you how to balance equation. And one of the methods is the try and error. When you just look at it like this, sometimes you'll be able to balance some equations. However, complex equation may require mathematical method. For this type of reaction, actually, we can balance it easily by just putting 2 here and putting 2 here, ensuring that there is equal number of atoms of each element on both the reactants and the product side. Okay, there's 4 hydrogen here and 4 hydrogen here, 2 oxygen here and 2 oxygen here. So we've done the first step to write the balanced chemical reaction. The next thing is we need to convert the quantities to mole. When you are dealing with in stoichiometry, when you are applying it to any equation, whatever you are given, you need to convert it to mole. And in this question, we said we are given 4 gram of hydrogen. Let's look at it. What is 4 gram of hydrogen? Using the equation, mole is equals to mass over molar mass. Okay, so the mass of hydrogen is 4 over molar mass of hydrogen is relative atomic mass of hydrogen times the 2, which is equals to 2. So the mole of 2 gram of hydrogen gas is equals to 2. Okay, now we were given this. Now we know the mole of gas that we have, but from our equation we need to know How many mole of gas is formed when how many mole of hydrogen react with how many mole of oxygen? We can see that 2 mole 2 moles of hydrogen will give 2 moles of water, meaning that whatever you give, you get when hydrogen reacts with oxygen, right? So this is 2:2, which is actually 1:1, right? Meaning that the mole of the hydrogen that you give into the reaction, if there is adequate oxygen, okay, the same mole of hydrogen that is given into the reaction will be the same mole of water that is formed. Okay, so they are in ratio 1:1. Okay, so and this we have calculated that we are given 2 moles of hydrogen, right? Oh, I think we need to be following these steps. I think we have converted the given quantities to mole. Then we determine the molar ratio. The molar ratio in the reactant is 2 to 2, okay? And which is 1:1. And now they say calculate the moles of the desired substance. The mole of the desired substance that will be given, since we have 2 moles of hydrogen, will be 2 moles of water, okay? 2 moles of water, okay? Now, the next step is convert moles back to the desired units. Our desired unit here is gram, which is the mass. That's what they ask us to calculate, but we have mole here. So, to get the mass of water, we use the formula, same formula, mole is equals to mass over molar mass. So, the mass is equals to mole times molar mass. And we know the mole of the water that we will get is 2 times the molar mass of water, which is 18. So this will be equal to 36 gram. All right. So this is our final answer. 36 gram of 36 gram of water will be formed from 2 moles of hydrogen. Now let's look at this second example. They said 3.2 gram of nitrogen oxide reacts with 2 gram of oxygen. Identify the limiting reactant. Now, in a chemical reaction in stoichiometry, there are limiting reactants, okay? Limiting reactant and also the excess reactant. Limiting reactant is the reactant that is not that does not match the quantity of the other one that is available. Now, let's as we go forward, you understand better what I mean. Okay. The first step is to write balanced chemical reaction. The chemical reaction is NO plus O2, which will give us nitrogen 4 oxide, right? We need to balance this equation. There's one nitrogen here, one nitrogen here. There's one ox 3 oxygen here. There is 2 oxygen here. Let's balance it. Let's put 2 here and let's put 2 here. Now it's balanced, right? Good. They say convert the given quantity to moles. We are given 3.2 gram of nitrogen oxide and 2 gram of oxygen. We need to convert each of them to mole. And don't forget the formula you use is mole is equals to mass over molar mass. And for nitric oxide, this will be equals to 3.2 divided by the molar mass of nitrogen is 14 plus 16, which is 30, right? And for oxygen, we are given 2.0 gram divided by the molar mass of oxygen here is 16 times 2, which is 32, right? Good. Now, we've converted the given quantity into moles. The next step is to determine the molar ratio Now, let's determine the molar ratio in the equation. The molar ratio here is when you give 2 moles of nitrogen oxide, you get when you present 2 moles of nitrogen oxide, 1 mole of oxygen will react with it. So this is 2 ratio 1, right? Now, let's look at its ratio here, okay? But before we do that, let's simplify this, okay? Let's use our calculator. That is 3.2 divided by 30, which is equals to, this one is 0, for my calculator here is 0.1067, okay? And here, 2 divided by 32, 2 divided by 32 is equals to, this is equals to 0.0625. You can leave it in 3 decimal places, okay? Now, having gotten this, let's look at the ratio between them. The ratio here is, let's look at it. The ratio is this divided by this, 0.1067 divided by 0.0625 is equals to. So what we got here is 1 point, the ratio, is 1.7, okay, which is less than this. And what this means is there is more than enough oxygen for the necessary hydrogen, okay? So that is why you got lower ratio when compared to this, okay? So meaning that only 1.7 is available for 1 mole of oxygen, okay, instead of 2, meaning that the limiting reactant here is the nitrogen oxide here, okay? So I think I have overstepped here. We determined the molar ratio already, calculate the moles of the desired substance, and the mole of the desired substance, convert mole back to the desired unit. These 2 steps is not applicable here, okay? Because what we are trying to get is the limiting reactants, which we have gotten here. So here, the nitrogen oxide is the limiting reactant because it cannot supply enough number of moles that is required by the oxygen, okay? Now, having gone through all the examples, these are exercises for us to solve, okay? Let's look at this one. They said in the reaction, this reaction is famous. Okay, hydrogen reacting with oxygen to form water. How many moles of water are produced when 4 moles of hydrogen react with 2 moles of oxygen? Okay, let's look at it. We know that when 2 moles of oxygen react with 1 mole of, when 2 moles of hydrogen react with 1 mole of oxygen, it gives us 2 moles of water. Now they are asking how many moles of water are produced when 4 moles of hydrogen react with 2 moles. We can see now that what they are asking us is when 4 reacts with 2. We see everything is doubled. So get 4 moles of water produced. So the correct answer is D. Next question. How many grams of ammonia can be produced from 28 grams of nitrogen? I'll leave this question for you to solve. Don't forget to follow the steps that I earlier highlighted. The first thing is to convert this to mole, which is mass over molar mass. That's one, right? And they're asking us for how many grams of ammonia will be produced from 28 grams of nitrogen, right? Which is 1 mole of nitrogen. 1 mole of nitrogen, we know 1 mole of nitrogen produce 2 moles of ammonia, right? So now we've gotten it from this equation now. We have 2 moles of ammonia and we can calculate the mass of the ammonia that is equivalent to 2 moles of ammonia through the equation mass is equals to mole times molar mass. And we're given the molar mass of ammonia already. I think that wouldn't be difficult for us to solve, right? The answer is there. You can comment in the section below what your answer is, and let's see if we agree. Okay. Now, the third reaction, the third question. I think I will leave this one for you completely to answer. It should not be difficult for you with the kind of the example that we have done. But if you have problem solving it, let me know. You can write in the comment section below. Okay. And this is another question you can write. Okay. Thank you for listening. But before you go, kindly like this video. It takes a lot of effort for me to do it. Kindly like it, share for others to benefit, and subscribe to my channel. Okay, to encourage me to make more videos. Okay, thank you very much. I wish you the best. Bye bye.